Welcome back for part 3. In this session we're going to discuss about plates and plating techniques. So initially we're going to look at what plates are actually doing. So for example, on this model, if we've got a fracture in a bone, then we need to bridge that fracture over. We need to span over the area to transfer the load. So hopefully what's going to happen is we've lost the load bearing axis down the centre of the bone. So what we need to do is shift that load up through the bone, into the plate, and then back into the bone, restoring continuity and stabilisation. So with this, we're looking for standard plates where basically the screw head is going to engage through the plate into the bone, and it's the force of compression between the screw head on the plate and the plate against the bone which gives us that stability. And in this session, we're going to look how things have modified and moved on and with plating techniques. So firstly, what are we doing with the plate? If we've got a standard fracture and we line that fracture back up and we put a standard round hole plate on at the edges, we're going to create something called a neutralisation to make sure that we've neutralised that fracture. We're not getting any compression, we're not doing anything else, we're not bridging over, we're just neutralising the fracture down the side. So off the back of that, we can then look at something called a compression plate. A compression plate is going to force the ends of the bone together. You can only use compression plates where you've actually got integrity between the cortices. If you haven't got cylindrical integrity, it isn't going to work. You're going to damage the bone further. You're not going to help improve the stability. So it's important, you can only really use those for really your transverse fractures or mildly oblique fractures. If you start trying to do anything comminuted wise, you're getting no advantage by using that compression effect within the plate. And finally, we can use plates which are called bridging plates. Now, a bridging plate is where we may have an area of comminution. We've lost the bone integrity, we've lost that stability in the centre, and we're going to try and bridge over that area just to give it restoration, hold it in alignment. Now, sometimes a plate alone, we've got to be very careful with just that because we will get what's called cyclical fatigue. We'll end up stressing our plate and breaking our plate. So we've usually got to combine it in combination with other things, for example, an intramedullary pin down the centre of the bone or an external skeletal fixator. But those plates will apply on, they'll bridge over the gap. The thing to remember is one plate can act and do each of these individual things. So if we have a plate which has the capability to be a dynamic compression plate, it can either compress when it's applied, it can be applied in a neutralisation fashion, or it could be applied as a bridging fashion as well. So when we move on, we can then look at the different systems. So as we were saying, plating systems have developed. So when we look back to the original plates, the first plates came out, and these were what were called round hole plates. These can only be used in more of a neutralisation or a bridging fashion. We can't get compression with these. So this isn't a dynamic compression plate. We've got single round holes, we've got no threads within those holes, we've got a flat surface on the back of the plate, and this is going to be applied directly to the bone just to create stabilisation. So with time, as things have developed, we've moved on to that of the dynamic compression plate. And as you can see, we've got these elliptical shaped holes. And the way in which these work is that when we load these screws, depending on how we apply the screw, we can then force the ends of the bones to meet each other. And that creates this compression, which again, as we talked about earlier in the series, will allow a better form of healing. We'll get that primary heal, we'll get that direct healing rather than a big callus formation. So for example, for something like a radius, we don't necessarily want big callus formation, we don't want it to interfere with the ulna, therefore something like a dynamic compression plate would be a much better option for that. So as we then move on from those plates, we then moved into the locking plates. And the locking plates are whereby we have individual threads in each of the plates. So the screw is going to go into the plate, it's going to engage into the plate itself with a screw head, it's going to run the way through, and then it's going to lock into the bone. And this means we've got a single unit. So this looks much more like that of almost an internal skeletal fixator. We're using that plate, we don't need to be as worried about contouring the plate quite as much because we're not looking at that compression between the plate and the bone and the screw head. It's going to lock itself together as a single unit, which gives us a much stronger structure as well in it. Now, when we move on from those plates, we then look at these hybrid style plates. And these hybrid plates have a combination of both locking threads in them, but also dynamic compression. So what we can do with these plates is we can apply them, we can put a standard neutralisation screw in initially, but then we can apply screws which will give us dynamic compression. We can compress that fracture together and then follow that with locking screws. And in doing so, we've got the advantage of both effects. We're pushing those bone ends together, we're getting a primary union under compression, but we've also got the additional strength of those locking screws as well. So these are really, really good, but again, they can only be used in certain circumstances. So when we move on from these, we then start to look at things like the polyaxial systems. And this is where the EvoLox plate comes into its own. The EvoLox plate is a plate which can be contoured, it can be manipulated and bent over big angles. So for example, if we were looking at the bottom of the femur, we can see where we've got a distal fracture here, we've got a big bend in this bone. A standard plate is not going to want to bend around that angle to get purchase. And we may need to get additional screws into this distal aspect to make sure we've got the best form of fixation. And a single screw or two screws at the bottom isn't going to always give us that. So by using something like a locking plate, we've then got the ability to start bending these plates around, and it allows us to contour them much better. So for example, distal femoral fractures, they're really useful for, but also looking at things like the condylar fractures in the elbow, they can be really, really beneficial too as well. And this allows us a number of benefits. We've got the locking effect, we've got the ability to mould the plate to fit the bone. We've also got a nice matte finish, which though some people think it doesn't make a big difference when you're working in very bright lights and we're getting a lot of reflection, is a definite advantage to the system. So the other thing we can see on these is we've got what are called crumple zones built into them. This means that we can therefore bend the plate without distorting the node. And as we were saying in series 2, looking at these, we've got to be very careful that we don't distort these little nodes as we bend the plate. So it's really, really important to keep a close watch on those and use the little plugs in place to keep those stable throughout. So one of the things we've got to remember about plates is not only how we use them, but how we actually contour them and apply them to the bone. So one of the important things that we've already mentioned is particularly things like the dynamic compression plates. We need to make sure we've got that in close proximity to the bone. When we start using the locking plates, that isn't as important, but we need it to lay below the skin and the muscle to create an aesthetic outcome where possible. So one of the things that we use is plate benders. Now this is a more simplistic set of plate benders, and this particular set can be used in two ways. It can be used both for your standard plates when we're looking at them with the flat ends, but also we can then turn them over and then we've got the change in the end for them as well, where we can use it for our polyaxial locking plates as well. So if we're going to contour a plate, for example with this plate, we could slide it in both sides, and then we can bend the plate accordingly to make sure that it then fits to where we want it. We can twist it and create rotation and torsion through it, and we can bend it backwards and forwards. Through adjusting where the plate is within the plate benders will allow us to focus on where we actually want to contour that plate. And sometimes we may use a contouring guide, which is a little strip of metal, to run over the bone first. Now when we move on to the polyaxial systems, we can then turn them over, and these are designed where the actual little head will lock into each place. So this particular plate is a 3.5 plate. On the other side, it's got a smaller head that's designed for the 2.7 plate. We can put that in, and then we can use that to basically manipulate the plate as to where we want it. So we can twist it backwards and forwards. We can also turn the plate bender around, and we can use it the similar way with the dynamic compression, and we can twist it on its end as well, which allows us to manipulate the plate in a torsional force as well, allowing us to manipulate things around. So with that, the benefit is that not only can we increase the range of angles within the screw head, we can also use the screw itself, because we have a 20-degree variation within that screw head to angle that screw to make sure we can engage it into the best parts of the bone. So when we then look at using our drill guides, this also makes a difference. For our standard drill guides, when we're using something like a dynamic compression plate, we have what's called a neutral end, where we can see on here we've got a central hole, and on the opposite end we've got a loaded end. So if we place the neutral end into our plate, we can then find that it's going to sit into our plate, and when we drill that hole, it's going to leave our screw in the centre, and it's neither going to move the bone forward or backwards. If we twist the loaded guide around, and we've got a little arrow, that is going to point into the direction where we want to move that plate. So if we now place that drill guide in and drill our hole here, when we then screw our screw in, it's going to move that underlying bone forward within that in the direction of the arrow. So it's really important that when you do these drills, you make sure that your loaded guide is in the right direction and you're using it in the right fashion. Now where things change slightly is that when we're using the locking plates, we're using a completely different drill guide. These drill guides are designed where they actually have a thread on them, and they actually lock into the thread. So we can see that we've got a single unit. Now, we can alter the angulation slightly where we want to drill this by putting the thread on an angle as we screw it in, and it will hold on at a different angle, and our screw head will still engage. But this way, we know that when we put our screw in through the hole, it's going to engage perfectly into that plate, and that's really important. What you don't want to do is do these freehand, because unfortunately you will end up in a situation whereby your screw will not fit into your head. And as mentioned before, be really careful that when we're screwing them in, we check first that we're in the right orientation of our plate. We don't want to try and apply our plate upside down by putting it in the wrong direction, because unfortunately our screw head will not engage. So finally, one of the things that I'd like to make mention of is things like the screwdrivers and the drills that we're using. So we use different size screws. So for example, if we are putting in a 2.5 or 2.7 screw, we'll be using a 2mm drill bit. If we're using a 3.5 screw, we'll use a 2.5 drill bit. Now that does change. When we're using the 3.5 polyaxial system, we need to make sure we use a 2.7 drill bit instead. And this is clearly labelled up on the guide in the N2 catalogue. So that brings us to the end of our part 3. Hopefully you'll be able to join us in part 4, where we'll be talking about pins and wires.